Okay, once again, at the end of the last video, things were kind of wacky, and my computer crashed. Well, actually, the computer didn't crash, but QuickTime crashed. So let's jump back in here and get back to where we were, and we'll finish this up real quickly. So I got a little bit of work to do to get things back to where they were. So bear with me. Sorry about that. I want to come in and get my data and attach the data. And let's just take a look at it and show you that we're dealing with the same thing here. Now, what I was wanting to do here is I was wanting to do the pairwise comparisons. What we found so far, we found with our repeated measures design that we have statistical significance, which says that the the 6-month exercise training program had a statistically significant effect on this fitness treatment, or I'm sorry, this fitness level that we've talked about. So what we'd like to do now is we'd like to do pairwise comparisons, kind of a post hoc analysis to tap into to what we've done. Now let's just go back again. We ran the analysis using. I'm trying to get guys, bear with me here. Trying to find out what I've done and what I need to do. So we ran the model using the AOV function, and so we need this across the interval, and then we've got to add our error for, well, we've got to do factor subject and interval, yes. And then we do summary for model, and we see we get statistical significance. And again, we've talked about this, and I wouldn't be repeating it except for QuickTime crashed on me. So I need to do that. Okay. Now the next thing I wanted to do the pairwise comparison, and to do that, what I would do, I would go with and tell the let's see, I did call it data, right? Yeah. So with data, and I want to do a pairwise t-test of fitness over interval. And I want to adjust the p-values because I'm going to be doing multiple comparisons using the home method. And I want paired equal true. Now, when I get this, I get pairwise comparisons adjusting for the p-value. And I think there are other ones. We'll take a look at that in just a second. But what you can see is we have statistical significance between two pairs. The pre is statistically significant with the 6-month, and the 3 and the 6-month are statistically significant at the 0.05. So, in addition to writing up, like I showed you previously, about the 6-month exercise training program being statistically significant, you'd probably want to report this and say something to the effect a pairwise comparison analysis was conducted, which found statistically significant differences between 3-month and 6-month intervals, as well as between pre and 6-month month measures. Okay, so I would do something like that when you write it up, and you'll get the opportunity to share your brilliance with me when you do your assignment on repeated measures. Now, guys, the final thing I want to do is the effect size, and what I'm going to use here is the eta squared approach. And the interpretations of eta squared, I'll tell you, this is where it drives you crazy, because you look at literature and it gives you different kind of thresholds. But I'm pretty comfortable with a 0.01 being a small effect, about a 0.06 being a moderate effect, and about I'd probably say about 0.15 being a strong effect size. Okay, and it's the effect size for these are actually pretty easy to calculate. It's just going to be the sum of squares for the effect divided by the sum of squares for the total. So what we'll end up with here is our effect size is going to be the sum of squares for the effect, which is 143.44 divided by the total. And our effect size here is 0.71. So we have a very, very strong effect size, which is just kind of adding to the narrative here that there is truly something going on for the exercise program that that these participants are engaging in as it affects their fitness score. So if you designed this, good for you. You're making people healthier, which is cool. I guess that's it. I'm trying to think if there's anything else I want to share with you on this. No, really, I guess not. So hopefully you know more now about repeated measures than you did when you woke up this morning. It's a very powerful tool. Now, I tell you, I was going to get into power, but let's leave that for another situation. I tell you what, let me just bring it up while we're at it. If I open up G power, you can see that we would go to an F test, which is pretty obvious. But we have ANOVA repeated measures between design and with M factors. So let's see, I would probably choose this one. So if we have our effect size, I forget what was it, it was 0.71. We want that, we want our, no, I don't want this, because I want to do a post hoc and see our power. So again, what, 0.71, yeah. And error probability 0.05. Total sample size was 18. We had number of groups were 3. Number of measurements were 6. Correlation. Now this one's a kind of weird. When you do multiple correlations, these things don't follow normal distributions, so they're not going to be additive. So what I would probably do is I'd look at the correlation between, let me go back over here. I would look at the correlation between let's see how we're going to do this. Yeah, I would look, I'm not really sure how I would do this. I'd have to think about this. But what I would do is I would look at the correlation of fitness from pre to 3 month And now we look at pre to 6 month, and then the correlation between 3 month and 6 month. You got to again. Let me see if I can. I don't think this is going to work, but I know it's not going to work. Yeah. So we'd have to get a correlation matrix, and I've done these before, but I don't remember how to do them. So, but that'd be something we could figure out together real easily. But what I would probably do is I would use the minimum correlation. It's going to have an effect on our power, but I think it's going to have a conservative effect. So let's just say that the minimum correlation was 0.61, and non-sphericity correction, I don't remember what that was, but it seemed like to me it was about a 0.78 or something like that. And I can calculate, and something is going wacky on me here. Let's see. We have a crazy power. Yeah, I'm not sure. See, number of groups. That actually maybe should have been, number of groups would be 6. And the measurement should be 3. Yeah, this actually makes more sense. Yeah, okay, we got those backwards. And the power here, you can see we have a lot of power. And so, you know, if there were any fear now, it would be, are we detecting a difference? Because we have so much power, are we detecting a difference that's statistically significant, but not significantly different? So, guys, that's it. That's all I got for you. Sorry for the confusion on the video, but having some computer issues here lately. I don't know what's going on. So, take care.